J.C. Chiao, Engineering.
Electromagnetic wave have to go through all the ribs and tissues.
Dr. J.C. Chiao is describing an electronic device designed to be implanted in the human body. It's not science fiction. It's actually a new wave of medicine being developed today in his lab at UT Arlington. J.C. hopes these devices will one day help make diseases and chronic pain more bearable.
Engineer can bring a solution to the medicine in a total different perspective.
Drawing from his expertise in electrical engineering and a knack for listening to medical doctors, J.C. is seeking out new approaches to treating old health problems.
His collaborative nature is really important in helping him learn and understand where important problems are. And then he's able and creative enough to take his own discoveries and to make them useful.
J.C. grew up in Taiwan as the son of an electrical engineer. He earned degrees in electrical engineering at Taiwan University and at Caltech. After college, J.C. found work at various corporate labs. He soon realized he'd rather spend his time solving the problems of mankind than worrying about profits. That's what led him to UT Arlington in 2002.
Every time the acid or non-acid liquid flush through the esophagus, the impedance sensor will detect it.
At UTA, J.C. and his students are developing a radio frequency sensor that, when implanted in the esophagus, can detect whether drugs are effectively treating severe acid reflux that can lead to cancer. The sensor works without batteries or wires.
And we also have the device that's embedded in the stomach that can provide electrical current to stimulate the stomach tissue.
There's even a batteryless strain sensor that can detect esophagus wall pressure or bladder volume. J.C.'s team is collaborating with another professor to develop sensors called neurostimulators. They're designed to detect pain signals and then block them by transmitting electrical signals into neurons,
which is much more efficient with much less side effect than conventional way like morphine.
In yet another part of J.C.'s lab, they're working on a microfluidic platform that shows how prostate cancer cells move and grow.
You see, this cell is moving in two different directions. Yeah.
While many of his devices are in development or trial phases, J.C. already has group members in the clean room at UTA developing mass production processes in anticipation of future FDA approval. And J.C. looks forward to those approvals. As a lifelong diabetic, he knows the pain and discomfort disease can cause.
I feel very happy whenever we have some research result that can go into clinical use. I feel a personal accomplishment knowing I help a lot of people.